So Docker is a containerization platform for developing, deploying and running the applications. You can run any application. You can run any application as a container using Docker. That application can be Java web application or web server software like Nginx or database software like MySQL, MongoDB, Couchbase DB. You can run softwares. You can run your softwares, your applications as a containers. That can be web applications like Java based web applications using Tomcat, or it can be Python based applications or Node.js based applications. Not only applications, you can run your web server softwares like Nginx, HTTPD, HAProxy, and your database softwares also like MySQL, MongoDB, Couchbase DB as a containers. And also you can run other softwares like messaging queue softwares like RabbitMQ, Kafka, or in-memory softwares like Redis. You take any software, you can run that software as a container. Docker is a containerization platform for developing and deploying applications as a containers. So Docker is lightweight. Docker runs directly on the host machine kernel. Docker directly runs on the host machine kernel, which we already discussed, right? So Docker enables you to separate your application, your software with underlying infrastructure. Docker enables you to separate your application, your software with underlying infrastructure, with underlying hardware. So you create an application package using Docker and you can run that package on any infrastructure, on any hardware. That can be your local laptop on which you have a Docker installed, or that can be on-premise servers on which you have Docker installed, or that can be cloud servers like AWS or Azure. Wherever you have a Docker, wherever you have a Docker, you can run your application as a container. So your application is separated with underlying infrastructure with the help of Docker. So Docker is a containerization platform using which we can package your application and all its dependencies. Application and all its dependencies together. So using Docker, what we are trying to do, we are trying to package our application and all its dependencies. These two together, your application and your required softwares, configurations, and all those things, we can create a package of application and all its dependencies together. And wherever you have a Docker, you can run that package. Wherever you have a Docker, you can run that package. These two, you can create a package using Docker. We can create a package with your application code and all its dependencies together so that your application works seamlessly in any environment, whether it's a dev or test or production. If that package works in one server, that package works in another server without any issues, because is the softwares and configurations is getting changed if you are deploying that same package in another Docker server, that can be dev or production or QA, that software versions and configurations, no. So it remains same. It will work seamlessly in any environment. So Docker is an open platform for developers and system administrators. Docker can be used by developers and operations teams like us, DevOps engineers like system administrators, to build. We can build and we can ship, we can run applications as a containers. Karthik is asking what is the difference between EKS and ECS. First of all, I am discussing Docker. Let's understand Docker. Don't ask questions on Kubernetes, because people will get diverted and they'll get confused. So this is still Docker. It is not Kubernetes. So what is EKS? I will discuss in Kubernetes, not here. So Docker is an open platform for developers and system administrators to build and ship our applications using Docker. Build in the sense we can create a package. Build in the sense we can create a package with application code and all its dependencies together like this. As I already told last week, we can create a package like this using Docker. Required application code and its configurations. We can build these packages and we can ship. Ship in the sense, what is the meaning of ship or shipping? Moving. We can move those packages from one location to another location. So we can maintain these packages. We can maintain these packages. We can ship these packages to some central repositories, artifactories like Nexus or JFrog. You can maintain. We can maintain these packages. We can ship or we can maintain these packages in a central repositories. Like Nexus, JFrog, or there is some services, managed services like ECR or ACR like that repositories. You can ship those packages here, and wherever you need, you can run that package. You can run that package wherever you have a Docker. Suppose this is my server. This is my server. Have an operating system. I have an operating system. We call it as a host operating system. And wherever I have a Docker software, we can pull these packages. We can pull these packages. We call it as a Docker images. We can pull these packages and we can create a container. We can run a container. So wherever Docker is required, wherever Docker is there, you can run these packages. So Docker is separating your application with underlying infrastructure. You can run your applications as a containers wherever you have a Docker. That can be your local laptop, that can be on-premise servers, that can be cloud servers. So using Docker, we can build your applications with required dependencies and we can ship those packages and we can run those packages wherever you need. So Docker is an open platform for developers and system administrators to build, ship and run applications. Docker is available in two editions. Docker comes with two editions. Docker comes with two editions. One is community edition. So Docker is a containerization software. Using Docker, we can build and ship our applications as a containers. Docker comes with two editions. One is community edition and another one is enterprise edition. Docker comes with two editions, community edition and enterprise edition. So community edition, the name itself it is saying community edition. It's an open source, it's free to use. It's open source, free to use. Free to use. Community, free to use. This enterprise edition, the name itself it is saying EE, Docker. CE stands for community edition. Docker EE stands for enterprise edition. So this enterprise edition is not free. We need to purchase a license. It's a licensed software. It's a licensed software. You need to purchase the license to use that enterprise edition. But whether it's a community edition, whether it's an enterprise edition, the Docker works same. The Docker works in a same way. But what is the advantage if we go for an enterprise edition? Like any typical enterprise edition, what is the advantage? We will get a support, vendor support. We will get a vendor support. What do you mean by vendor support? If there are some issues or defects in the Docker software, if there are issues or some defects, if there are some defects, there are some bugs in the Docker software. I am talking about Docker software, not in your application. If there are issues, if there are defects or bugs in your application which you are running in a Docker, Docker is not responsible. Docker is not responsible for that. You need to fix the issues or bugs which is there in your application which is running in a Docker. But if there are issues or defects in the Docker software itself, there is a vendor support. So Docker will support if there are any issues or with Docker which you are using, there is a vendor support, and also some additional features, some additional features, some additional features. So community edition will not have a vendor support. It will have a vendor support. Docker Enterprise Edition will have a vendor support and also additional features comes. Like examples, additional features in the Docker Enterprise Edition if you are using, there is something called UCP software. There is something called DTR. Some additional softwares. This UCP stands for Universal Control Plane. Universal Control Plane. This is a GUI. GUI to manage containers and Docker servers. It's a GUI to manage containers and Docker servers, UCP. And there is something called a DTR. There is something called DTR. DTR stands for Docker Trusted Registry. Docker Trusted Registry. Registry like Nexus, the way you have a Nexus JFrog, right? So they are going to give some additional software like a Docker Trusted Registry in which you can maintain those images, those Docker packages. So only difference, vendor support some additional features, but all the Docker concepts remain same. But most of the people are using only community edition. Most of the people are using only community edition, Docker community edition. They are not using enterprise edition because they are using combination of Docker and Kubernetes. Most of the people are using combination of Docker and Kubernetes. Docker for building and running the containers, Kubernetes to manage those containers. Kubernetes to manage those containers. So most of the people are using community edition. So Docker comes in two editions, community edition and enterprise edition. Now, as I already told, we already discussed in detail why containers. We discussed already last class why containers, what is the advantage of containers. But let me quickly recap why containers. Why we need to build and ship our application as a containers. The developers. Why developers will prefer containers and why IT in the sense operations team. Why we prefer also, let's understand. So developers will prefer because we can quickly create a ready to run packaged applications. We can quickly create ready to run packaged applications, which means using Docker we can create a package like this. We can create a package like this, ready to run packages. Now, if I want to deploy that application here in my server, in whatever server, that can be a local laptop, that can be a some on-premise server or cloud server, do I need to do this setup again? If I am using Docker, do I need to do this setup again in the server in which I want to deploy that application? Do I need to do this? Like configuring the required softwares and environment and configurations here. If I have already done this, if I am using Docker, do I need to do this again here? No, not required because you created ready to run packages. Your package, your Docker package itself has everything required softwares, configurations, and your application code. You no need to do this here. I can quickly run this application. But what is the only software which is required here to run that package, that Docker image? The only software which is required here is Docker, the Docker software. So if I have a Docker software, we can deploy that application quickly. Using Docker, we can create ready to run packaged applications, and we can automate the testing, integration, packaging, all these things. Automation in the sense, instead of creating these things manually, instead of taking the code manually, instead of creating an application package like this manually, instead of creating a Docker package and is pushing the Docker package to the registries and creating those packages as a containers here, instead of manually doing all these things, we can do the automation. We can do the integration, automation, everything, continuous integration and continuous deployment using pipelines, using CI/CD pipelines. We can automate this process also, creating a Docker package, pushing the Docker package to the repositories, and creating a containers out of those Docker images in whatever servers you want to do. We can automate this one also. We can automate integration, packaging, and deployment of containers using CI/CD pipelines like using Jenkins or Azure DevOps or Bamboo or Travis CI or GitLab. You can use any CI/CD tool to automate the process of creating, deploying those applications as a containers. And it will reduce or eliminate platform compatibility issues, which we already discussed. Since we are creating a package with all the required softwares and configurations, it will work seamlessly in any server where you are deploying, wherever you have a Docker. It will reduce or eliminate that platform compatibility issues. And containers are the best locations to run microservices. So Docker containers are the best location to run your microservices, or microservices can be deployed as a containers. So what is microservice, what is monolithic, I will discuss later. So Docker, the container, is a best way to run microservices. That's why developer will prefer containers. Now IT in the sense operations team, like DevOps team. In IT, our operations team, DevOps team will prefer containers because it will improve the speed and frequency and reliability of deployments. So if I am deploying applications as a containers, we can improve the speed and frequency and reliability of deployments. So we can quickly deploy and we can frequently deploy the applications as a containers, and we can make application lifecycle efficient, consistent, repeatable, which means as an operations guy, as a DevOps guy, you can create a pipeline. You can create a pipeline for your application. Like whenever there is a change in the code, you can get that code, you can create a Docker package and you can deploy the Docker package. So you can configure once, you create a pipeline once, and you can run multiple times whenever there is a change in the code. And it will eliminate that platform compatibility issues, and also it will improve the production application resiliency, scale in and scale out. We can scale in and scale out the containers also. What do you mean by scale in and scale out? As we already know, let's say we deployed one application as a container. Out of this package, we created a container. If there is a lot of load, if there is a lot of load on that application which is running as a container, instead of one replica, instead of one container, we can scale it to two containers like this. Based on the demand, you can do scale in and scale out of your containers. That using container orchestration softwares like Docker Swarm or Kubernetes, we can scale in and scale out these containers. The way we are scaling and scale out the servers, right? Whenever there is a load, here also we can scale in and scale out the containers using some container orchestration softwares like Docker Swarm or Kubernetes. So that's why people will prefer containers. Now, as I already told, Docker is what type of tool? Is it comes under SCM category, source code management, or is it comes under CI/CD category like Jenkins, CI/CD tool like Jenkins or Bamboo or GitLab or Azure DevOps like that. No. Docker is a containerization tool. Containerization tool. Using Docker, we can build and run our applications as a containers. The vendor. Who is the vendor of this Docker? I mean to say who developed this Docker software? There is company called Docker. They developed. Is it an open source? Is Docker is an open source? Yes, only some extent. Only some extent. Is it open source completely? No, because it has two editions. It has two editions. Community edition is free. Enterprise edition is not free. So to some extent it is open source. Now operating system cross platform. Operating system cross platform. What do you mean by cross platform? Which means we can install Docker on any OS. We can install Docker on any OS, which means we can run Docker on Windows or on Mac, on Linux also. So we can install, we can install or we can run Docker on any OS. We can install Docker on Linux or we can install Docker on Mac. We can install Docker on Windows also. That can be a server, that can be a server, or that can be your local laptop or desktop. That can be a server, or that can be your local laptop or desktop. That can be Windows OS, Linux, or Mac. You can install Docker. It's a cross platform. So this is the official URL of that Docker. This is the official website. Docker.com. This is the official website. One second. So this is the official website. www.docker.com. www.docker.com. This is the official website of Docker. So what is Docker? All these things, if you want to learn, there is a in detail documentation here. We have something called a docs.docker.com documentation. There is something called docs.docker.com documentation. This one, docs.docker.com. Detailed documentation is also there. So what is Docker? How to install Docker? All this in detail documentation here we have. So Docker. What is Docker? Docker overview. All these things. So as we already discussed, Docker is an open platform for developing, shipping, and running your applications. Right? Using Docker, we can quickly deliver our applications. And this architecture we will discuss in some time. So this is the official website www.docker.com, and there is a documentation, in detail documentation, how to install, how to use Docker. There is a detailed documentation. I will discuss about this architecture in some time. Now we can install Docker in Linux also, as I already told. We can install Docker in Windows also, and we can install Docker in Mac also, Mac OS. The advantage, the benefits of Docker. We already discussed all these things, but let me quickly explain here. Portable. Portable. What do you mean by portable? In general, guys, in a plain English, what do you mean by portable? Easy to move. Easy to move from one system to another system. Easy to move or easy to carry. Which means I deployed one application as a container in one server. Is it easy to port to other server? Is it easy to port or easy to move to other server? The same application as a container? Yes. So you have a package. You have a Docker package. You have a Docker package. You created a Docker package like this. You deploy that package as a container in this server. You deployed this Docker package as a container in one server. It is easy to carry or port into some other server. So wherever you have a Docker installed, you can deploy that application, that Docker package in another server also. It is easy to port, easy to carry. It's portable. Now, cost saving. Cost saving because containers take less resources. Containers will take less resources. Container will consume less CPU, less memory. Containers are lightweight. Containers will not have a full blown operating system. So, cost saving and scalable. Scalable in the sense, based on the load, we can increase and decrease. We can do horizontal scaling, we can do vertical scaling also in the containers. We can horizontally scale our containers, we can vertically scale our containers. Vertical in the sense, I can increase the limits. I can increase the limits, that CPU and memory limits while creating a container. Let's consider I have set some limits. If required, I can increase those limits, CPU and memory limits for that container, vertical scaling. Horizontal in the sense, instead of one container for that application, instead of one container for that application based on the load, I can replicate. Horizontally, I can scale multiple containers. Docker is scalable and we can quickly start and stop the containers. Easy to deploy, it is lightweight, all these things, all these advantages which we already know. Now, let's understand this architecture. Before I install Docker, let's understand this architecture. Docker architecture. I am talking about this diagram. In the docs.docker.com also I have shown, right? This architecture. So, Docker overview. Here, I am talking about this architecture. Docker architecture. Docker uses client server architecture. There is a client in the Docker, there is a server in the Docker. Docker uses client server architecture. Basically, Docker is one software. Docker is one software which is developed in Go language, guys. Docker is developed in one language called Go. Golang, or we call it as a Go language. Docker is developed in one language called Golang. The way we have a Java, the way we have a Python, the way we have a Node.js, right? Similarly, there is one programmatic language called Go language, that is invented and implemented by Google. So, Docker is basically developed in Go language. That is Go are basically Google language. That Go language. Go language is developed or implemented or invented by Google. So this Docker software is developed in Go language. It uses client server architecture. Now, if you see this architecture, we have three important components. Client, client, and a Docker host, or we call it as a Docker daemon, and there is something called registry. So if you see this diagram, in the Docker architecture, we have three important components. One is client, Docker client, and we call it as a Docker daemon or Docker host, and there is something called registry. We have three important components. First, let's understand this Docker daemon or Docker host. What is this Docker daemon or this Docker host? So Docker daemon or that Docker host, basically the Docker host is nothing but a server. The server on which Docker is installed. So the Docker daemon is basically, it's a software. It's a software. Docker daemon is nothing but one software that a Docker daemon will execute the commands. That a Docker daemon will execute the commands that execute the commands sent by the client. Sent by the client. So Docker daemon will process the commands sent by the client, that client software. So Docker daemon is one software, one process, and whatever instructions, whatever commands are sent by that client, that a Docker daemon will process those commands. Whether that can be a creating a image, or that can be a creating a container, or that can be a pushing a image to the registry, or that can be a pulling image from the registry. Based on the command which we are executing, that a Docker daemon will process, that a Docker daemon or Docker host, we call it as a Docker host or Docker daemon, that will be processing the commands, that can be pulling an image from the registry, or that can be creating a container out of that image, like that. Now we have a client, Docker client. Client. Client is Docker client. Something like command line interface, CLI. Docker CLI, command line interface. So this Docker client, that command line interface CLI, we can use that Docker client, that CLI. Using that CLI, we can send the commands or instructions to the Docker daemon. So we can execute some commands like this using CLI. Using this client software, you can execute some commands, Docker commands, like that can be a pulling a image, or that can be a creating an image, or that can be creating a container. So we can execute commands. This client will send or communicate. This client will communicate with this Docker daemon, and this Docker daemon will execute or process these instructions. It's a client software. Using this client software, using this Docker client, we can interact with the Docker daemon. Docker daemon will process or execute those instructions. And we have something called registry. We have something called registry. Registry, like Nexus registry, JFrog registry, like that, we have something called registry. We already use this registries concept, guys. Bhaskar sir might have already explained that Nexus registry, JFrog registry, like that. So similarly, here also we have a registry. That can be Nexus registry, that can be JFrog registry. So what this registry contains, or what do we maintain this in the registries? Those packages, the Docker packages, the Docker images, the Docker packages, the Docker images. Basically, we call it the Docker package as an image. So the way we guys are maintaining application packages like jar files, var files, Java based application packages, the way you guys are maintaining Node.js packages, or the way we guys are maintaining RPM packages or Debian packages in these registries. Similarly, we can maintain Docker packages in the Docker registries in a central location. In a central location, we can maintain those packages. Wherever you need, you can pull that package, the Docker package, and create a container. We have a registry, Docker registry. So this registry contains images, various images that can be used. And if required, we can create our own image also. If required, we can create our own image for our application, our own package for our application, and we can upload those images into these registries. So there is the way we have a Maven registries, the way we have a Maven registries, right? Similarly, we have a Docker registries. In the Maven registries, you are going to maintain application packages. In the Docker registries, you are going to maintain Docker packages. The Docker package contains required softwares, configurations, along with your application code also if required. So in the Docker also we have some central repository. In the Docker also we have some central repository. In the Docker also we have some central repository. We call that as a Docker hub. We call that as a Docker hub. I am talking about this one. In the Docker also we have some central repository. The way we have a Maven central repository, we have a Docker central repository like this hub.docker.com. So this hub.docker.com is basically a central repository, where we will have public Docker packages, public images. The way we have a Maven central repository, in that Maven central repository we have Maven packages, that jar files, var files, like that. Here we have a Docker hub. In the Docker hub we have lot of packages. If you see in the Docker hub we have lot of packages like this: Postgres, Python, Nginx, Redis, MySQL, HTTPD, Mongo, Java, like this. So these are like images. If you see, let me search with Tomcat. I have some image. So this is a Docker image or Docker package. What this Docker package or this Docker image contains basically, if I use this image which is there in the Docker hub to create a container, what this Tomcat image or Tomcat package contains? It is going to contain the Java software along with Tomcat software also. So we have Docker registry. That Docker registry contains public images that can be used. So there is a central repository maintained by Docker that we call it as a Docker hub. The Docker hub contains various public images that can be used, and also we can create our own image, and we can maintain our own images in our own registry also. So this is like a central server where we can maintain these packages. We can pull the packages to the Docker servers, or we can push the packages to the Docker, to this registry. We can pull the packages, that images, from this Docker registry, or we can push the images to the Docker registry. We can build our own images also, and we can create a containers out of that images. So we have a client, we have a server, and we have registry. So when we are installing Docker in any server, that can be your local laptop or desktop, the Docker software comes with two components. If you are installing Docker like this, you have a client, that client software. That client is nothing but a CLI. Command line interface, and we have something called a Docker daemon. Docker D or Docker daemon. It's a process. It's a server, Docker daemon or Docker process. Now, using this client, we can interact with Docker daemon. Using this client, we are interacting with this Docker daemon. So what commands we can use? If required, I can build a packages like this. I can build the images by executing some command. By interacting with the Docker daemon, I can create some packages. This Docker packages with required softwares and required configurations, I can create a package, and I can create images. I mean to say, I can build the images and I can push the images. So we have something called registry. So I can build image by executing some Docker command. I can build the image and I can push that image to the registry. If required, I can push the image to the registry. If the image is already there in this registry, I can pull that image to create a container. So What is image, what is container, how to create image, how to create container, we will discuss later. But you need to understand this architecture. There is something called Docker daemon. There is something called a client. Using client, we will interact with the daemon to create a images or create a containers like that. And we can maintain the images in the registry. So Docker is having one registry, we call that as a Docker hub. It's a public registry. It's a public registry. We have a lot of images. The way you have a central repository for Maven, we have a central repository for Docker. That is Docker hub, where we see lot of images. Now, this Docker is developed in Go language, guys. This Docker is developed in Go language. But do we need to learn Go language, or do we need to write any Go script to create images or create a containers or manage the containers? No. So Docker is developed in Go language. Docker is developed in Go language. And when you are installing Docker, that code will be deployed. That code developed for Docker will be deployed, and this client will communicate with the Docker daemon. So we can just use commands, but in the background, this CLI is also developed in Go language. This Docker daemon is also developed in Go language, but we no need to learn, or we no need to worry about that Go language. We can execute a command in the background. That CLI will communicate with this Docker daemon, and we can maintain the images in the registry in a central server. Suppose I have a one more Docker server. I have a one more Docker server like this. I have a one more Docker server like this. I install Docker. So that Docker will have this something like this. Now I can build images in this server. I can push that image to the registry. If required, here I can pull that image from this registry. I can download this image from the registry, this Docker package from the registry, to create a container. To create a container, I can pull this image here. Using that image, I can create a container. For now, what is image, what is container, I will discuss later. But is everyone clear the architecture? What is client, what is the daemon, what is registry? So Docker daemon is one software. Docker daemon is one software. To interact with the Docker daemon, we need a client software. We need a client software. So using Docker, we can build the images, we can push the images, we can pull the images. But if I want to maintain that image centrally, we will use this registry concept. In the registry, we will store the images. The way we stored that jar files, var files in the Nexus, similarly, these Docker packages we can store in the registry, like Nexus registry, JFrog registry, like that. Is everyone clear? What is client, what is daemon, and what is registry? Now, let me install Docker now. I will do the installation. First, we will install Docker. As I already told, you can install Docker for Windows, you can install Docker for Mac, you can install Docker for Linux also. As a developer, if you want to build Docker images, and if I want to run locally, and if I want to test, you can install Docker in your local laptop also, local desktop also, or we can install in Mac, we can install in Windows, we can install in Linux. Now Docker is a cross platform. Now if you see the installation, Docker setup, right? If you see, sorry, one second. So installing this Docker engine or Docker software, you can see you can install for Windows, you can install for Mac, and you can install for Linux. That can be if you are using CentOS or Debian or Fedora or SE Linux or Ubuntu. So you can install Docker for Linux. You can install Docker for Windows also. Windows, Docker for Windows or Docker for Mac is also there. So Docker desktop for Mac, Docker desktop for Windows is also there. And we can install in the Linux also like CentOS, Debian, Fedora, Ubuntu, all these things. This community edition we can install with free of cost. You no need to pay anything. Now, if I want to install Docker for Windows in your local laptop, you have to meet with some prerequisites. So, suppose you want to install Docker, this is your local laptop. This is your local laptop or server, but it's a Windows server. It's a Windows server or laptop or desktop. If it is a Windows server or laptop or desktop, now you have a operating system. What operating system you will have, because this is Windows only, you will have a Windows OS. So here, if you want to install Docker, you need to meet some prerequisites. What is that prerequisites? Let me tell you. You need to enable Hyper-V. You need to enable Hyper-V. What is Hyper-V? In your Windows laptop or desktop, you need to enable Hyper-V. What is Hyper-V? Hyper-V is a virtualization software. It's a virtualization software. Why we need to enable Hyper-V in your Windows laptop or desktop to install Docker? Because Docker will create a VM. Docker will internally create one VM. On top of that VM, Docker will run. It will not directly run on the Windows. This Docker will not directly run on the Windows. Docker will run on Linux and it will create a VM. So we need to enable Hyper-V. You need to enable Hyper-V. So here, why we need to enable Hyper-V? Because Docker will work on top of Linux. Even though you are installing Docker in Windows, it will create one VM. That's why we need to enable Hyper-V. Then Docker gets installed on top of that VM, then it will create a containers. So if you want to install Docker for Windows, if you see the prerequisites, the system requirements. Suppose you want to install Docker on Windows, Docker desktop on Windows, right? So we need to have some system requirements. Your Windows must meet the following requirements. Either you need to have a WSL2 backend, your Windows should have WSL2, Windows Subsystem for Linux, or you need to have a Hyper-V. You need to have a Hyper-V enabled. So you can install Docker for Windows in Windows 11 64-bit Pro version or higher version or education version or home version also it will work. It will work in Windows 11, Windows 10. It will work on Windows 11 and Windows 10. It will work. You need to have a Hyper-V enabled. And your Windows laptop should have 4 GB RAM minimum. Your Windows laptop will have 4 GB minimum and you should have a 64-bit processor. So you need to enable Hyper-V. Why we need to enable Hyper-V? As I already told, here your Docker will create a containers. That Docker will create a containers and that containers will be isolated from each other. Isolated from each other. Now here, if it is a Windows laptop, we need to enable Hyper-V. Why? Because it is going to create one VM, guys. It is going to create one VM. What do you mean by VM? It is going to create one Linux VM. It is going to create one Linux VM on top of Windows. What do you mean by VM? Virtual machine. It is going to create a Linux VM on top of Windows. Then Docker will work on top of that VM. It will not directly work with Windows. Because it is going to leverage, it is going to leverage that namespaces C groups concept, that namespaces C group concept. It's a Linux features, that kernel features. So Docker is going to leverage that namespace C groups concept. That's why we need to enable Hyper-V. Now, when it comes to containers, there are two types of containers: Linux-based containers, Linux-based containers, and Windows-based containers. Linux-based containers, Windows-based containers. So, which one we are widely using? Basically, Linux-based containers only. We are going to use Linux-based containers only. We are using widely that Linux-based containers. So, Windows-based containers. Suppose you have some softwares which will work only on Windows. Suppose if you have some softwares which will work only on Windows, like your Microsoft products, like your Microsoft softwares, Microsoft products, it will work only on Windows. It will not work on Linux. So if you are Dockerizing that type of softwares, if you are Dockerizing, if you are Dockerizing that Windows-based softwares as a containers, which will work only with Windows system. So in that case, you have option. You have option in your Windows laptop or desktop. In your Windows or laptop or desktop, you can run Windows-based containers and also Linux-based containers. Suppose if it is a Windows-based container and it has some binaries, Windows binaries, Windows-based softwares. Now, if it is a Windows-based softwares, it will work directly with the Windows OS. This will work directly with Windows OS. So in that time, you have option here. Here, when you are installing Docker in Windows, you have options. You can enable Windows containers, enable or disable. You can enable or disable Windows-based containers. So when you install Docker for desktop here, if you enable Windows-based containers, then you can run only Windows-based softwares only here as a container. But if you are using some Linux-based containers, some Linux binaries are there to interact with kernel, some Linux binaries are there. You cannot run Linux by enabling Windows containers here. If you want to run Linux based containers, you need to disable this Windows based container in your Docker desktop, in your Windows desktop. You need to disable. So if you disable how Docker works, it will create one VM within your laptop. Within your laptop or desktop, it will create one VM. One VM, that is Linux VM, Linux OS. On top of that, this Linux container works. This Linux container works. So there are two types of containers: Linux based containers and Windows based containers. So can we run Linux based containers and Windows based containers in a Docker? If Docker is installed on Windows, yes. If Docker is installed on Windows, Docker desktop is installed on Windows, you can run Linux based containers and also Windows based containers. But you have an option to enable or disable Windows containers feature. You have an option to enable or disable Windows containers feature. So if you want to install Docker for Windows, what is the prerequisite they are saying first? Windows is OS. Windows is OS. Sunday is asking one question. Is in AWS is Hyper-V is enabled? AWS is OS? Is AWS is OS? No. AWS is not a OS. AWS is a cloud provider. So they are going to provide the infrastructure for you. So there is a physical server. Using that physical server, you can create a virtual machines. Now I am talking about in Windows also you need to enable Hyper-V. Windows is one system, one OS. On top of that OS, on top of that system, you need to enable Hyper-V to create a VM. Docker will internally create a VM. That is what the meaning of this Hyper-V should be enabled in Windows. Now, here I need to enable Hyper-V so that it will create a Linux VM so that we can run the Linux containers. Suppose I want to run Windows containers, I need to disable this option. Then I can run a Windows containers. That is how in Windows it works in a local laptop or desktop. Now, if I am trying to install Docker in Linux directly, suppose I have a Linux VM, suppose I have a Linux machine, it's already a Linux machine. Do I need to enable anything here? Not required. I can directly run Docker here. I can directly run Docker here. But if Docker is installed on Linux, can I run Windows based containers? If you have any Windows based softwares, the prerequisite is that software should have a Windows OS. Will it work like this? Does this Windows based container can work in the Linux system where I have Docker installed? No. So sometimes in the interview they are asking this question. So what is Windows based containers? What is Linux based containers, like that? Windows based containers are nothing but the softwares which you are trying to run in that container is depends on Windows OS. As I already told, does container will have a full blown operating system? No. Container will not have an operating system. Container will use host operating system. So if it is a Windows based software, do I need to have a Windows OS in that system? If it is a Windows based container, yes, I need to have a Windows OS. But if it is a Linux based container, if it is a Linux based container, do you need to have some kind of a Linux OS in that system? Yes. But here in the Windows, I can run Linux containers also. In the Windows laptop or desktop, I can install Docker. I can run Linux containers. But I need to enable Hyper-V. Why I need to enable Hyper-V? As I already told, Docker will be working on top of that Linux VM if it is a Linux based containers. If required, we can install Docker in Linux also. Directly it will work. If required, I can install Docker in Mac also, local laptop. If I am using MacBook, I can install Docker for Mac. I can install Docker for Mac also. The way I can install Docker for Windows, I can install Docker for Mac software. But Mac is built on top of what again? The Mac is built on top of what again? Mac is built on top of Linux only. So Mac is built on top of Linux only. That in the background it is using Linux only. So I can install Mac, that Docker for Mac. If you are using Apple chip, you can download this one. If you are using Intel chip, you can download and install this one. But most of the cases, in real time, you are going to use Linux containers only. So in Windows also, if you are installing, you need to enable that Hyper-V and you can install Docker in Windows. So how to enable Hyper-V in Windows? It is in your local laptop, in your BIOS settings, it is there. In your local laptop, in BIOS settings. That is nothing to do with the Docker, that is nothing to do with the DevOps. You need to know some basics of computer. That's why we are saying at least you need to know some basics of computer. How to manage your computer, your laptop. So in the BIOS settings, you can enable Hyper-V. Otherwise, if you don't know, enable Hyper-V in Windows 10 if you are using Windows 10. So Microsoft will give how to enable Hyper-V. Using PowerShell also you can enable, or maybe through settings, right? In your Windows laptop, you have some right click on the Windows button. In the bottom, you have that Windows button, right? You can go to the programs and features. Here you have something called Hyper-V. You need to select this one as per this. So you have this type of settings you need to do in your laptop or desktop if you want to install. Guys, you should know basics of computers. Without knowing what is computer, what is Windows, what is Linux, like that, it will be difficult to learn. For now, anyhow, I'm not installing Docker. I'm not installing Docker in Windows because in real time we will be deploying in the servers only. For development purpose, as a DevOps engineer or as a developer, for development, for local development and local testing, you can install Docker in your laptop. That can be Windows laptop or that can be MacBook, or you are using Ubuntu laptop. You can install Docker in your local laptop also for local developmental and testing purpose. But in real time, for end users, are we going to deploy our applications as a containers in the developers' laptops or desktops like that? No. We are going to deploy in the dedicated servers. The dedicated servers. So we will create a server and I will install Docker in that server. I will install Docker in that server. Now, you can use on-premise servers. You can use on-premise servers or you can use cloud servers also. You can run Docker anywhere. You can run Docker on any infrastructure. That can be laptop, that can be desktop, or that can be server which is running in your own data center, or that can be cloud server like AWS or Azure or GCP. But wherever you are running Docker, it's a Docker. Docker concepts will not change. The Docker commands and concepts will not change. Irrespective on what infrastructure you are installing, the Docker remains same. Okay. Now, I have a AWS. I have a AWS. Here I can create a servers. Here I can create a servers. I can create a Windows server. I can create a Linux server based on requirement, and we can use that server. Now, I am going to create a Linux server in which I will install Docker. I am going to create a Linux server in which I am going to install Docker. So Docker Community Edition can be installed anywhere in Linux, free to use, right? So in Linux also you can install, in Mac also you can install, in Windows also you can install, in your local laptop, like local laptop, desktop or server also. If you want to install in Windows, this is the prerequisites. This is the prerequisites for Windows. Prerequisites for this Windows. You can download this one, this OS, Windows 10 or Windows 11 Home Edition, Enterprise Edition or whatever it is, and also Hyper-V. Hyper-V should be enabled. It should be 64 core processor and it should have a 4 GB system, 4 GB RAM. Now, as I already told, there are two types of containers, right? Windows based containers and Linux based containers. If you are using Windows for Docker, you can switch between Windows and Linux containers. You can switch between Windows and Linux containers. To run Windows containers, you need Windows 10 or Windows 11 Professional or Enterprise Edition. Windows Home, Windows Home Edition or Education Edition will allow you to run only Linux containers. Windows Home or Education Edition, right, will allow you to run only Linux containers. So you can install Docker for Windows by downloading that Docker exe file, and you can follow these instructions to install the Docker. Now I am not installing Docker for Windows. If required, you can install Docker for Mac also. If required, you can install Docker for Mac also. Mac, right? System requirements. Mac OS must be this version like that, and you can install, you can download that GPG, this file, this Docker DMG package for Mac are like this. You can download these things. If you are using Intel chip, this link you can use. It will download like this. If you are using Apple chip, you can use like this. Then you double click on this one. It will install in your local laptop, Mac. For now, I am going to install Docker on Linux. Docker on Linux. As I already told, we can install Docker in Linux also. It supports different flavors. In Linux, we have lot of distributions. In Linux, we have lot of distributions. One is CentOS, we have CentOS, and we have Ubuntu, we have Debian, like this. What else? We have RHEL, SUSE Linux, like this. There are a lot of things like CentOS, Ubuntu, Debian, Red Hat, Amazon Linux. AWS is having one Linux distribution, Amazon Linux, Fedora, all these things. But all are operating systems. All are just an OS. It's an operating system. But does your software will be work differently if you are installing in CentOS, Debian or Ubuntu or Red Hat like that? The softwares will behave differently if you are using that software in a different OS? No. Like, let's take this use case. You are using Tomcat. You are installing Tomcat. Does Tomcat will work or behave differently if I install Tomcat in Windows system or if I install Tomcat in Linux system? Is it going to behave differently? No. So Docker also same. Whether you are using on CentOS, whether you are using on Ubuntu, whether you are using on Mac or Windows, Docker works similar way. And again, if you are installing your local laptop or some other servers, on-premise servers or cloud servers, that doesn't matter. Docker is a Docker. So Docker Community Edition can be installed in Linux. That can be any Linux except this one, except Red Hat. Because Docker Community Edition is not officially supported by Red Hat. Docker Community Edition is not officially supported by Red Hat, and Red Hat also not officially supporting Docker Community Edition. Docker Community Edition is not officially supported by Red Hat and vice versa. So we can still install Docker. We can still install Docker in Red Hat. The Docker Community Edition in Red Hat we can still install, but there is no support. There is no official support. What do you mean by official support? If there is any compatibility issues with the Docker software on Red Hat OS, does Docker will take care of those issues? Does Docker will fix those issues if there is any compatibility issues in the Docker Community Edition with Red Hat? No, because there is no official support for Red Hat, because there is some reasons for that. There is some reasons for that. Red Hat is enterprise Linux. Red Hat is enterprise Linux. What do you mean by enterprise Linux? Is it free to use that Red Hat OS? No. Paid version. And also Red Hat has their own containerization software. Red Hat has their own containerization software. They want to promote their containerization software instead of Docker. So Red Hat has their own containerization software. So the Podman, this is also containerization software. That Podman, this Podman is also containerization software. So who is implementing or who is maintaining this one? It's again by Red Hat only. Again by Red Hat. This is also containerization runtime. So this is containerization runtime, right? You can run containers. This Podman. So this is supported or developed by Red Hat. So they want to promote their one. That's why they are not using. They are not supporting community edition, which doesn't mean you cannot install. You can still install. I can install Docker in Red Hat. I can create a containers. I can run the containers in the Red Hat also. But there is no official support from the Red Hat as well as Docker. Is everyone clear? What do you mean by this one? Docker Community Edition will not support Red Hat means we can still install. but there is no official support. Now, what I will do, I'll create some Ubuntu servers. Ubuntu server. What is Ubuntu, guys? What is Ubuntu? The way we have a Red Hat, Ubuntu is what again? Ubuntu is another distribution, another flavor of Linux. Again, it's a Linux OS only, Ubuntu. Now, I will demonstrate directly in AWS. Since I don't have any on-premise environment, right? I don't have Linux. So what I will do, I will use AWS cloud. In AWS, can I create an infrastructure like a server? Can I create a server that can be a Linux server, that can be Windows server or Mac server also in Linux, AWS? Yes. So AWS is an infrastructure platform. AWS is a cloud provider. In AWS, we can create a server. In that server, you can configure whatever OS you want to configure and you can install whatever software you want to install. Now I will take one AWS server. I hope everyone has a AWS account because from day one everyone is practicing the softwares whatever we discussed. All the softwares, all the tools we have discussed and configured and installed in AWS. But if some people joined directly for Docker and Kubernetes, make sure you create an account in AWS and we will create a required servers in AWS and we will understand all these concepts. Now, I am creating one server. Now I will select, all these concepts in AWS we already discussed. I am creating a server. I am giving a tag like this, Docker server. Now, instead of selecting Red Hat throughout the sessions, I will use Ubuntu. This AMI. In AWS we already discussed AMI. AMI is a pre-configured package which comes with some OS. Now, if I am selecting this AMI, what OS will be configured on top of the EC2 instance? Ubuntu OS. Ubuntu. So we selected this AMI, Ubuntu AMI. For practicing purpose, I am just selecting T2.micro. For practicing purpose, I just selected T2.micro. So how much CPU, how much memory we will be getting for this server? 1 GB and 1 core CPU. 1 GB and 1 core CPU. Sometimes in the interviews they are asking one question. How many containers can be created in one Docker server or system or host or node? All are same, guys. Don't get confused. Server, system, host, node, all are same. So Docker server, Docker system, Docker host, Docker node, all the names are same. So how many containers can be created in one Docker system or that server? That depends on what, guys? That depends on what? That depends on your system resources. What do you mean by system resource? CPU, RAM, etc. CPU and RAM. RAM is nothing but memory. CPU, memory, your hardware resources, your system resources. Because whenever we are creating a container is nothing but some process, some software, some process will be running. That process will take some CPU and memory, which means that container will take some CPU and memory. So if I create a system, suppose I am creating one server, this is 1 GB 1 core CPU. Is it possible for me to create tens of containers 10 containers, 20 containers, 30 containers like that in that system if my system capacity is very less? No. So this is very, very important. How many containers can be created in one Docker server? That one system. This is common in the interviews. So that depends on what? That depends on this one. That depends on your system resources. So is everyone clear? This is very widely asked in the interviews also. How many containers can be created? Is there any fixed number like that? 1, 2, 3 like that? No. That depends on your system resources. Now, if I am selecting T2.micro, I am total CPU is one CPU and one memory, 1 GB memory. OS will also take some CPU and memory because on top of that VM, you are booting the OS. OS will take some CPU and memory. And with whatever memory and CPU left, I can create few containers. But will I able to create tens of containers, hundreds of containers like that? No. So, how many containers can be created? That depends on your resources, system resources. So, I am selecting T2.micro just for practicing purpose. This is sufficient. You no need to go for high configuration server. And again, whether you are selecting Ubuntu, whether you are selecting Ubuntu, whether you are selecting CentOS or Amazon, or whether you are selecting T2.micro or T2.large, X large, double X large, triple X large, does the concept of Docker will change? The way we are going to create a containers, build the containers and manage the containers? No. So, how much each container is taking, that depends on what also I will explain. When I go for a commands, when I go for a Docker commands, how to know each container, how much CPU, how much memory it is taking, we will understand all these things. First, understand the basics. Without knowing these basics, you will not understand anything, whatever I do later. So, we are selecting T2.micro. We are selecting this PEM file to SSH. For now, I am creating in a default VPC only because I don't want to again make things complex by creating a servers in a custom VPC in a private network, because you need to connect to the jump server, from jump server you need to SSH to your private server like that. I don't want to make things complex here. I want you to focus on the Docker, learning Docker. In real time you are going to create your Docker servers or Kubernetes servers which you are going to use in a private subnet, private VPCs only. For now, I don't want to make things complex again. I want you to focus on the Docker because you already know what is private subnet, what is public subnet, what is how it works. So I don't want to again make the things complex. In real time, you are going to create all these servers in a private subnets only. For now, I'll create in a public subnet that is in a default VPC. In a default VPC, I am creating that server so that you can focus on the Docker rather than that networking part. That VPC, private subnet, public subnet, all those things you can leave it. For now, we are creating in a default VPC only. I am creating one server. By selecting Ubuntu, I have created one server. Now, in this server, I will install Docker. Let me wait for some time. Server is still getting created. Server is still getting created. Let me install Docker in that server. I will SSH to this server. I will SSH to this server. So this is, let me SSH from my local laptop. From my local laptop, I am using this Mac terminal and I have a PEM file. Whatever PEM file I have used while creating that server, I have a PEM file in my local laptop. So I am SSHing to that server, Linux server, from my local laptop. Now, what is the username? If you created a Ubuntu system, what is the username, guys? If you see, Here itself you can see what is the username, the default username of that Ubuntu system. The username is Ubuntu. The username is Ubuntu, not EC to -, user. The default username for that Ubuntu system is Ubuntu. So we connected to that system. Now here we don't have a Docker software. If I execute some commands like this, if I am executing some commands like this, Docker commands, what we are getting? You read this error message. What you are getting? Command Docker not found. What does it mean? Do you have that Docker software installed in this system? No. So as of now, we don't have Docker software installed. Docker can be installed in different ways. Docker can be installed in different ways. You can install using some convenience script, or you can install using package manager also. Installation can be done in different ways, guys. Installation can be done in different ways. Now you can install by following official instructions. You can install by following official instructions. So you have a official documentation, right? Install Docker. Suppose you want to install Docker in Ubuntu. Ubuntu, if you see, they have given some installation instructions, right? Installing Docker on Ubuntu, right? They are saying this is required. Now, if you have any older versions, you can remove those older versions by executing this command. So this APT, what is this APT? The way we have a M, here we have a APT. What is APT, guys? And what is M? What is APT? This is nothing to do with the Docker. This is nothing to do with the Docker. That M or APT, those are package managers. Those are package managers to manage the Linux packages. M is a package manager for CentOS, Red Hat, Amazon Linux. You can install or update or remove Linux packages in the Linux system. And APT is for what? APT is for Ubuntu, Debian, Ubuntu. This APT will work. Now, if required, you can remove. If required, you can remove any old versions. If you have any old version of the Docker software, you can remove by executing this command. Now, you can install using repositories. What do you mean by this repository? The way you have a repositories for jar files, var files, similarly we have a repositories for these packages also, M packages or APT packages. So from that APT files or RPM files, if you are using M, it is going to manage RPM files. If you are using APT like APT files, so you can download those packages from these repositories, M repository or APT repositories. You can install by using that repositories. You can set up the repositories like this. You can set up the repositories where we have those packages, right? You can execute these commands to install Docker. You can execute these commands to install Docker. This is the official way, and there is a convenience script. There is some script, get.docker.com. There is one script, guys. There is one script, get.docker.com. So if you see, this is shell script. Who written this script? Basically, this script is written by Docker itself, that Docker company itself. If you see, this is one shell script. You can see there is a cbang line and there are some commands. So based on the underlying OS, first it is checking what is the OS, of that system in which I am going to execute this script. So it is going to check what OS, whether it's a Ubuntu or CentOS or like that. There is a script. It is checking that what OS is part of that system, right? So there is a script here. This is a shell script written by Docker itself. This is shell script written by Docker itself. It is checking what is the underlying OS, whether it's a CentOS or whether it's Amazon Linux. You can see if it is a Ubuntu, if it is a Ubuntu, it is going to execute some script. If it is some other OS, it is going to execute some script. Now you can see there are some functions to identify what OS it is. So it is identifying what OS it is. Then based on that OS, it is executing some command or script. It is executing some command or script. So this script is written by Docker itself. I can get this script, shell script, I can run this script. I can get this script and I can run this script. I can do something like this also. In a single line, I can do something like this. Sudo curl -f ssl get.docker.com. Using curl command, I am getting that script and I am passing it to bash. In a single line, I can execute something like this. What it does, it is getting that script, this complete script, and it is passing it to bash. So that script get executed based on the underlying OS. Based on the underlying OS, the Docker community edition gets installed. This Docker community version get installed. So this is one way. Other way is package manager. This we call it as a convenience script. Convenience script. So that script is written by Docker itself. You can execute this command in Linux. This will work for most of the Linux. But if you execute this script in the Red Hat, it will clearly say a message: Docker Community Edition cannot be installed in Red Hat. If you execute this script in the Red Hat system, it will clearly give a message: Docker Community Edition cannot be installed in Red Hat. This is one way. Otherwise, you can use package manager. Here itself they are giving something like this. So sudo apt install docker.io. So what is this? This is package manager. So apt is what? apt is a package manager. The way you have yum install, you have apt install. This is the package. So this package gets downloaded and installed. The Docker software gets downloaded and installed. Whatever way you want to install, you can install. Why we are using sudo here? Again, it is nothing to do with the Docker. Why we are using sudo? Because as a non-root user, do you have a permissions to install those packages? As a non-root user? No. So that's why we are using sudo root. So you can do this way. If it is a Ubuntu, or you can do this way. You can execute this one in Ubuntu, CentOS, Fedora also. This command, it will work. Now let me execute something like this. In this system, I am executing sudo apt install docker.io. I am getting a message. This is not available. This package is not available. First, what I will do, I will update the package manager. Sudo apt update. The way sudo apt update. The way we have yum update, I am doing a apt update. I am updating that package manager. Then I will execute this command which will install Docker. So Docker software is getting downloaded and Docker software is getting installed using that package manager. Now here we have two things. Client is also there, daemon is also there. That client is also there, that daemon is also there. Two things, client and server. Now if you see, Docker software is installed, but when I execute some command like this, any Docker command, I am getting some message. Let's understand what is this message. When I am executing some commands like this, Docker related commands, I will explain what is this commands later. If I execute some commands like this, I am getting a message. Got permission denied while connecting to the Docker daemon. So we have a client, we have a server. Client is trying to communicate with the Docker daemon to process that commands. So first check whether that Docker daemon process is running or not. First, let's check whether the Docker daemon software is running or not. How to check whether the Docker daemon process is running or not? Linux commands, you already know troubleshooting. How to check whether the Docker daemon is running or not? You can use ps, ps command. If you see ps-ef, let me say grep Docker. Do you have some Docker daemon? You can see this one, Docker D. This Docker D. The Docker D stands for Docker daemon. So do you have a Docker daemon process running? No, na. What is this, man? If it is no, what is this? If it is not running, will it show this entry first of all? Govindu is saying no. If the Docker daemon is not running, do you see this record when you are executing ps-ef? What is ps-ef in the Linux? You might learn. The process, whatever process which is running in that system, that ps will display. So we have process, this docker d stands for Docker daemon. The Docker daemon process is running, and since I used package manager, it has created a service in the Linux. I can check like this also, sudo service Docker status. If you see, is the Docker daemon is running? You can see here also active running on this process ID. On which process ID Docker daemon is running in that system? The Docker daemon is running in this system on 22236. You can see that one here. When you are executing ps-ef, you can see that one 2236. So Docker daemon is running, but still, why I am getting that error? Because of the permissions. So as a normal user, as a non-root user, as a normal user, Docker daemon is running, but still I am not able to interact with the Docker daemon using client, using that CLI. Client, I am not able to interact. Why I am not able to interact? Because permissions. Permissions. So as a non-root user, as a which user I am executing this Docker commands, that Docker CLI commands? As a non-root user, as a normal user, as a Ubuntu user. So as a Ubuntu user, I am trying to execute these Docker commands, it is not working. If I use sudo, is it working? These commands, whatever I was executing last time, so it is working with sudo. But I don't want to use sudo, or let's say you don't have a sudo permissions to this. Let's say you don't have a sudo permissions to this user. I don't want to grant sudo access for this user, but still I want to interact with the Docker. What we can do? We can add this user to the Docker group. So when we install Docker, there is a group called Docker is created. When we install Docker, there is a group called Docker is created. If this user is part of the Docker group, then he will able to communicate. Then he will be able to communicate that Ubuntu. So now, how to add user to the group? Linux commands you already know. I want to add user to the group. I don't want to create a group. I don't want to create a group. I want to add a user to the group. People are saying different commands. User add, group add. User add, what user add will do and what group add will do. Group add will create a group. User add will create a user. But my question here is, I want to add user to the group. I don't want to create a group. I don't want to create a user. Come on, guys. What you learned in the Linux? People are saying different answers. CH mode. CH mode is changing the permissions to the folders. There is something called user mod. User mod. This you have learned in Linux. You already forgot Linux. Huh? So there is something called user mod -a g. What is -a? Adding group, appending. Adding in the sense appending. We are appending. We are not changing the primary group of that user, but we are appending that this user to that group also, which means something like this: user mod -ag Docker and Ubuntu. What is Docker? Docker here is group. What is Ubuntu here? What is Ubuntu here? This user. Otherwise, you can use something like this also, $user. What this $user returns, guys? Now, is this $user returns this one? The same? Yes. So you can use $user or you can use Ubuntu like this. Now I have added Ubuntu user to the Docker group. But still, is it working without sudo? Is it working? Even though that Ubuntu user is part of that group, is it working? No. It is not working because in the current session, in the current SSH session, it won't reflect. I need to create or open a new SSH session. So what I will do? I will close this SSH session by executing exit command. So if I exit, the SSH session is closed. So I came back and again I will SSH. Again I will SSH to that same machine. So new SSH session is created. Now if you see, as a normal user also, am I able to execute these commands now? All these commands, the Docker related commands? Yes. So we install Docker. We install Docker. So today, just install Docker, go through the recording and understand whatever has been discussed today. In today's session, just install Docker by creating one server. So tomorrow I will continue with actual concepts like what is Docker file, what is Docker image, what is container, how to create a container, what is registry, what is repository. All these things I will continue tomorrow, guys. From tomorrow onwards, most of the things is like labs only. So tomorrow onwards, it is like hands-on. It is like a labs only. So today, you just install Docker. From here, I will continue tomorrow. Any question? If you have, feel free to ask. Otherwise, I will stop the session here. I will continue tomorrow.